Right, today we're going to talk about the arc length and the area of a sector of a circle. So an arc length is really just how long it is from here to here. Okay, so in order to figure that out, what we need to have is we need to have the angle measure of what we would call a central angle. Do you guys agree with me? That's a central angle. Okay, so if I have that angle measure right here, that would tell me how much of this circle would be included in this arc measure right here. And what I mean by that is this, okay? If I broke this circumference into 4 equal parts, let's just kind of show you a picture up here and do it. Wouldn't I know that this would have to be 90 degrees, 90 degrees, 90 degrees, 90 degrees because of the 360 degrees that a circle adds up to be, right? So at the same thing here then, if I know that this circumference, let's say the circumference is 20, don't I know that it also breaks the circumference into 4 equal parts? So what would be the length from here to here? 5. And the length from here to here? 5. The length from here to here? 5 and 5. Because that circumference would also be broken up into those equal parts. Are you following me on that? Okay, so the reason why on the arc length we need this angle right here is because if we know how many degrees it is out of the total circle, it will find that piece of the circumference for us. Okay, so we do the angle measure over 360 and we times it by 2 pi r. Does anybody remember what 2 pi r actually gives us? That's actually the circumference formula. So if I take my angle out of the 360 degrees and times it by the circumference, then it will find that piece of the circumference for me. Does that make sense what the formula is doing? Okay, so that's one formula. The other formula we're going to use today is the area of a sector. Now, a sector of a circle is that pi piece that we talked about yesterday. So if I want to know the area of this pi piece, well, really, if I know the whole area of the circle, which is pi r squared, and I times it by, again, this angle over 360, meaning finding that piece of the pi, how much of that piece of the pi I'm using, then I can find the area of just that shape right there. Does that kind of make sense to everybody what the two formulas are doing? Okay, so here we go. This one says find the arc length. So we're going to figure out how far it is from here to here, the arc length. The arc length formula says to do the degree of the angle over 360 and then times it by 2 pi r. So it's really just a matter of plugging our numbers into this formula. Do I know the degree of my piece of my pi that I'm looking for? The degree is 45. So I'm going to go 45 over 360. I'm going to times that by 2 and then by pi and then by the radius. Anybody know the radius of this? Yeah, it's 12. The length of my radius is 12. So then, you guys, it comes to be a calculator problem. We're just going to plug those numbers into our calculator and solve it and see what happens. So let me show you how I'm going to punch it in my calculator so my calculator can do it all in one nice big number. I'm going to do 45 over 360 as a fraction. So 45 over 360. And then I'll times it by 2. And then I can even just put the pi right next to it. And then I can times it by 12. So I times it by 2 pi and by 12. Are you seeing how I punched that in? When I hit enter, it's going to give me my answer in terms of pi. So my answer here would be 3 pi. But if I hit my arrows, it will give me that decimal point equivalent, which would be 9.42. So the answer we're going to be looking for today is 9.42. If you were in my Math 3 class, we would be leaving our answers in terms of pi because you would have a full understanding of what that is. But for today, we're going to go to decimal point numbers. Okay? Are there questions on how I found that? So the point of this really is that if this was 12, say it's meters, then what I found is that from here to here would be 12 meters long, and I could actually figure out how far or how many of these little pieces would fit into there if I wanted to, but it didn't ask us to. So what we're really doing today is just finding a piece of the arc or a piece of the area. So this time it says find the area of the sector. So I'm going to find how much area this piece of pie takes up. Now, did you notice it's the exact same circle as before? We're just going to use a different formula. So this time the formula says take the angle, and this little symbol right here is called theta. It's just a letter, a Greek alphabet letter that we use to say angle. So we have the angle over 360, and this times we're going to times it by pi r squared, because pi r squared is the area of a circle formula. So what's my angle measure? 45. And then I'm going to times it by pi, and then the radius squared. We said last time the radius was 12, so we're going to do 12 squared. And again, it just becomes a calculator problem. So put it on your calculator, use that as a fraction. It will be easier for you to punch in. So 45 over 360 times by pi. You don't even have to put a times by sign there when you're using pi. You can just put pi, and then you can put 12 squared, just like that, and then hit enter. It gives you the answer of 18 pi, which is our answer in terms of pi. And then if we hit the arrows, we get the 56.55 if we round that up. This answer would be in units squared because it's an area. Do you guys remember that anytime we have an area, we want to square the units of measurement because it's a length times width kind of a process there for area. Okay, questions on how I use that formula to find the area of the sector? We're good? All right, so again, this one says find the arc lengths. So I'm just going to go up and grab that arc length formula and write it down. It will be the angle over 360 times by the circumference formula, which is 2 pi r. So I'm going to plug my information in here. What's my angle? 120. And then times by 2 times by pi. And what's my radius this time? 4. So I'm plugging it in my calculator from there. So see if you can punch that in your calculator. Again, do that 120 over 360 as a fraction. It just will work easier that way. And when I did that, and you guys correct me if I'm wrong, but I got 8 pi over 3 in terms of pi. And when I hit my arrows, I got 8.38 if I round that. Did you guys get that same number? Thank you. Okay, this is a length, so it's just going to be centimeters. When we find the area, it would be centimeters squared. Okay, ready for the next one? All right, this says find the area of the shaded area. So we're actually doing this part. So tell me this, do I know this angle from here to here? Do I know how many degrees this whole circle has? How many degrees in an entire circle? Yeah. So can I find that angle measure by doing 360 minus 45? Would that give me that angle measure? So do 360 minus 45. And that angle measure that we're going to use is 315 degrees. So then we'll go grab that formula. It's the angle over 360 times pi r squared. The angle is 315. And what's the length of my radius? 4. So we're going to punch it in our calculator just like that. So when I punched it in my calculator, I just did it like that. When you hit enter, it's going to give you 14 pi. When you hit your arrows, it will be 43.98. And what's my measurement going to be in? Centimeters squared. Okay, questions on that? Doing good so far? I love it when it's just formulas. I'm like, I got this. I can plug stuff into formulas, right? All right, here's a story problem. Don't let the story problem confuse you. It's still exactly the same thing. We're just reading it from words instead. So it says if the measure of AB is 45 degrees, so that's an arc, right? So we could draw a circle if we wanted to. From A to B is 45 degrees, right? And the radius is 12, so from here to here is 12. What is the arc length? So here's a rule that I'm teaching you tomorrow that this story problem expects you to know, okay? The central angle and the arc length, or the arc angle, measure the same. So if the arc measures 45, then the angle also measures 45, okay? We're going to go over that rule a lot tomorrow, but you kind of need to know it for here. Although I bet you guys would have just used 45 over 360 and not thought twice about it, right? So we're going to use the formula for the arc length. The arc length is the angle over 360 times 2 pi r. And again, you can just remember when it's the length, it's the circumference formula. When it's the area formula times the angle over 360. So my angle is 45 over 360 times 2 pi, and then my radius is 12. You punch that in your calculator the way that that is. And what'd you get when you punched that in?
9.42.
You're right, 9.42. So interestingly enough, did we already do this problem on the front page? This was just in words instead of with the picture, right? We've got that same answer on the first page for a problem. Okay? All right, last problem here. It says, if the area of a circle is 36 centimeters squared and the measure of the arc is 85, what is the area of the sector formed by the angle? So I need to have that area formula. The area is equal to the angle over 360 times pi r squared. Okay. This problem doesn't make sense. It needs to say what is the radius, doesn't it? Because I already gave you the area. That's what I get when I copy problems off the internet. I've said that before, huh? Let's find the radius. Because that's the only part we're missing, right? Is the radius. So the area is 36. The angle is 85.